Hi, kid. Welcome back. You guys having fun yet? So much fun, so much sarcasm. Here's the deal. This is our last day for, I shouldn't say last day, last of 2 days for trig stuff. You'll have today's notes, and then on Tuesday, you'll have the video notes for day 2 and the assignment on day 2. The test that was scheduled for next week on Thursday, yesterday got pushed to Friday. Okay, so that we have time because of the block scheduling. We don't want to load you up and, well, you're going to do this, and by the way, you got to do all this. No, you should be able to, over the next, next couple days, get the video done, and for the 5-6 day 2, it's an application video. It goes pretty quick, or at least in my mind, I think it'll go pretty quick. And then the assignments itself. Today's law of cosines. We've done law of sines. Law of sines has kind of an issue when we're working with it, because when we're talking about the arc sine, I have that written. Gosh, I think I wrote that down wrong. Let me just double check that. Somebody goes through. Yeah, it's arc cosine, and that should be cosine. Yeah. We'll distinguish two angles from acute. Will not. Will. Sorry. I'm just making a change on my board here, guys. This is will. Distinguish obtuse angles from acute. Arc cosine will. An angle and a supplement will have the same. See, yeah, no, I had it right. I just wanted to make sure that I screwed up. No, it's arc sine will not distinguish angles. And I wanted to have that. So let's fix that real quick as we're going through. Remember that when we defined arc sine, we defined it from negative pi over 2 to pi over 2. And we defined arc cosine from 0 to pi. So arc cosine, arc sine will not. Arc cosine will distinguish between acute and obtuse angles. Arc sine won't. It'll just return the same. It's the same value for a 45-degree angle and the 135-degree angle. So it doesn't tell you the difference. So it's awfully nice to use the arc cosine when we do this. So we will be able to, as we go through, understand and use the law of cosines to solve triangles over side angle side or side side side. Now, find the area of triangles given side angle side or side side side. This area formula is something you did in geometry, okay, in chapter 10. And apply the law of cosines to real-world applications. We'll do the application tomorrow, okay, or on Monday's notes, Tuesday notes, being it's even, so that's Tuesday as we go. Arc cosine. As you look at this, I want you thinking the first thing is Pythagorean theorem. A squared, I know, but it's equal to b squared plus c squared minus 2bc cosine A. And in like manner, when we do this, next one, maybe I should point these out, b squared is equal to a squared plus c squared, the other 2 squared, 2 times ac cosine b and b. Here, they're pretty much the same idea throughout the formula if you're working with side b and angle b, okay? The others are put in the same position. Now, c squared equals a squared plus b squared minus 2ab cosine c. Now, I want to make sure you know a couple things as we go. If you're going a squared and you decide to go c squared plus b squared minus 2cb cosine a, it'll still work because multiplication is commutative. Okay, addition is commutative. It'll totally work. So you just got to make sure you recognize when you have that first one, the other 2 are squared, the sides, and then the other 2 are multiplied by 2 times the cosine of the angle of the side that's opposite. Okay, so keep that in mind. That's the pattern. So you don't really have to oh, geez, I got to memorize all 3 of these. No, it's the same thing. You just have to know which one you're working with. So as we're going through here, apparently I have not taken care of this, so let's get rid of this stuff and talk about what we're going through. Okay, so as we're stepping through today, keep in mind we're going to be solving for other parts of the triangle. And there are situations where you could use the law of sines, but the law of cosines is what we're working with today. So we can clarify those things. So the first thing I'm looking at when I'm checking out this triangle here is I've got angle A. I don't have an angle, but I don't have side C either. And I've got 11. So I'm going to use angle A, or I should say, I'm going to find side C using the information I have, because I have the angle C, I have B, and I have A. So I'm going to find side C. And I'm going to use side C to help me find angle A, and I'm also going to use side C to help me find angle B. Okay, so as we start, so we're going to start out with C squared, okay, as we go, because that's what I'm looking for. I've got A squared plus B squared minus 2AB, cosine, law of cosines of angle C. So now that I got that in there, I'm just going to pop in what I got. So I've got A is 11 squared. I've got B sitting out there at 5 squared. I got 2A and B, that's 55 if you want to just multiply them together right away. And I got cosine of C, which is 20. Okay, I've got 121 and 5, 146. 5 squared, 121 and 25, 146, minus 110, cosine of 20. And that's something I'm just going to pop in my calculator. Okay, as we get going, and I did a cheat sheet for these, so I didn't slow us down as we go. So I'm looking at C as 42.6, C squared, I should say, at 42.6. 42.6338. Now, keep in mind, I got stuff in my calculator. Now, I may have just rounded that to the fourth digit, but I took the square root when it was still in my calculator. So I'm going to take the square root and actually find the length C to be 6.529. So that's 6.529 as I'm stepping through. Okay? Are there any concerns on how I use the formula? Really, I mean, today is just formula rich today as I'm stepping through. Just being more familiar with it, how to deal with it, and putting it into your calculator. Fat fingeritis abounds. Okay, so you got to be careful about it. So the first thing was finding C. The next thing, I'm just going to find angle A. Okay, what the heck? We'll find angle A on this next one. Okay, so if I'm going to find angle A, and keep in mind, if I'm going to find angle A, I have some stuff already, and I'm just going to find angle A. And I'm going to use the law of cosines to help me with this. Okay, so we know how to do the manipulation and stuff. And before I plug in numbers, I'm going to manipulate the formula, okay, a little bit, okay, because I'm going to use the inverse cosine, or the arc's cosine, as we go through. Yes, sir?
Since you have C, couldn't you do C over sine C is equal to?
I could, but because we're working with law of cosines, I'm going to stay with that just so we're more familiar, so we can start getting a little bit more familiar with what we've got. Okay. As we go through, I've got the A, and remember A squared is equal to B squared plus C squared minus 2 BC cosine of A. Okay, but remember, we're looking for the cosine of A, and I'm going to manipulate these. I'm going to subtract B squared. I'm going to subtract C squared. So on the left side, I've got A squared minus B squared minus C squared is equal to negative 2 BC cosine of A. Well, I'm going to divide by negative 2 BC. Okay, same idea as I'm going through. It's just manipulation as I go of my formula. And now I'm going to take the arc cosine of both sides. So I have inverse cosine of A squared minus B squared minus C squared all over negative 2 BC is equal to the measure of angle A. Okay, and it's just me manipulating a formula, okay, that I know about. as I step through. Now, with that manipulation, I've got to remember I've got some numbers up here. If I can bring those back, my recall. I've got A is 11 and B is 5. And then my C I found. So I've got inverse cosine, A being 11, B being 5, C being 6.529 squared. That's my top. I got the opposite of 2, B, which is, again, 5, times C, which is 6.529, to get my measure of angle A. And now it's just me popping that in my calculator. Okay, and how I found it, again, algebra. I just manipulated and solved for the measure of angle A. Okay. Now hopefully we're popping that out and we get that the measure of angle A is 144.832. Yeah.
If my rounding was slightly different, would I be marked off?
No, I mean, I'm going to follow through, but always when you're rounding, always try to round once, just at the end. So we're going to be using exact answers throughout. So I know that that 6.529 that I've used, well, that's sketchy, but that should have been the most recent ants I have in my calculator. So I could use the ants and squared it without my round and taking care of that issue. Does that make sense? Okay. So yeah, the rounding's a tough thing with these, but because of the calculator, boy, you know, if you go out to the 6th or 7th digit, you should be golden, okay, on getting it within 3. Okay, any others, questions-wise? We okay with the value we found using the inverse cosine? Okay, now, keep in mind the relationship that we have to find our measure of angle B, because that's the only thing we have left, right? And we have triangle sum theorem. The 3 angles of the triangle add up to be 180. So my last one, I've got 20. I've got angle A is 144. So really, measure of angle B was missing. I think it's B that's missing. Yes, it's 180 minus 20 plus 144.832. And so I pop those in there and I get 15.168. I should probably get degrees in there too. Make sure I box in my answers so it's easy to find. Okay, is it making sense? Now, remember, I'm just using formulas, okay, as I step through on these. Questions? Now, let's check out what's going on in solving a side, 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 because you're given all 3 sides. Okay, on the next one. We'll get rid of this. And all I'm doing is, again, I'm finding angles on this. Okay, so if I'm finding angles, okay, and I'm looking at a squared is equal to b squared plus c squared minus 2bc sine of a. Now remember, it's got the same pattern. I have a squared. It's the other 2 values squared, the other 2 times 2 subtracting off, and then the angle A is not sine but cosine. Somebody's got to keep in mind what he's doing. So I've got cosine, okay, as I step through. Are you doing okay with the setup of the formula so far? Now, make sure we recognize we're looking for angles. So we're going to give a squared minus b squared minus c squared all over negative 2bc. Okay, it'll be this inverse cosine to find the measure of angle A. Okay, we just did that solve on the previous problem. These go through the equal sign, subtract b squared, subtract c squared, divide by that, negative 2bc, and I pop that information in my calculator once I pop it in. So now I got inverse cosine. A was 9, B is 7, C is 5, minus 2b, again, is 7, and c is 5. So that's the information that goes in my calculator to kick out my value for A, which is 95.739. Okay, make sure you can operate your calculator to get that value. Okay, it's kind of a big deal. Just because of the parentheses and the grouping symbols and that, you want to make sure you're covered with it as you go in. Biggest concern I have is that you would do this in your calculator and make sure it's done that way. Okay? So make sure you can operate it and come up with that value. Now, that was finding the measure of angle A, okay, as we go through. This next one, again, I'm just going to find the measure of angle B or C. I don't care which one I did. In my notes, I did the measure of angle B. Okay, so I'm going to stay with that so I have that calculation completed. All right? So when I'm doing the measure of angle B, again, B squared is what I'm going to deal with. Minus A is equal to A squared plus B squared minus 2AB cosine of angle B. Oh, yep, C squared. Thanks for calling me on that as I was going through. Plus C squared minus 2AC as we go through. So it should be the other two that I'm not looking for. Okay. Now, I just manipulate it. I've got this through. So now I've got the inverse cosine, B squared minus A squared minus C squared, all divided by negative 2AC, is going to give me my measure of angle B. Okay, as I pop into my numbers here, and I've got B being 7, so I've got inverse cosine, 7 squared, minus A, minus 9 squared, C, I got 5 squared, and then I've got my 2AC on the bottom, minus 2, A is 9, and C is 5. That hopefully will kick out a value of 33.357. Nope, excuse me, it's B, not C. 50.704. Okay, after I do that, I use triangle sum theorem to find the last angle. The measure of angle C is equal to 180 minus A and B. Got 95.739 plus 50.704. That was ugly. Let's bring that through and I'll clean that up. Still bad. 50.704. There we go, that's better. That should return my C value coming in as 33.557, I hope, for my degrees. Okay. Now, again, make sure that you can pop this in a calculator, because that's the biggest issue that you're going to come across is calculating and making sure everything on top is divided by everything on the bottom. If you just kind of write it out and you don't pay with the parentheses, you're just going to be dividing by negative 2 and then multiplying by the other two sides, and your answer will be very different. Matter of fact, I think with that, depending on the values, your calculator will return an error message because your ratio you're trying to work with is greater than, the range between negative 1 and 1 for an arc cosine. Okay. Now, the next two things are triangle area formulas. Okay, and one is working with sine and the two angles that make the angle, and the other one is working with something called Heron's formula. Okay, so we got just two examples left here. First one is working with central angle here. Now, a slight review, if you are working with a circumscribed polygon, or the circumscribing circle. Means that there's a circle going around the polygon and it goes through each of the vertices of the polygon. Okay, that's why the center of the polygon is called the center, because the radius of the polygon goes from the center to the vertices of the polygon itself, which are actually the radius of the circle that circumscribes it. Okay, so what I want you to realize is as we go through this, we got a polygon that's 1, 2, 3, 4, 5, 6, 7, 8. It's an octagon, and maybe I should have read the problem, but we have an octagon, and we can find that central angle by dividing by the number of sides. And it's a regular polygon. That's what's important about this. If it wasn't regular, I couldn't do what I'm about to do. Okay, I'd have to do each one separately. I'd have to have extra information about the polygon itself. But since it's a regular polygon, all the interior angles are the same, all the sides are the same, I can do what I'm about to do. 360 divided by 8 is 45, so that's my central angle, and we got to have our calculators in this case in degrees, so keep that in mind. So theta, that central angle, is 45 degrees. What's significant about this is that we are using this equation. Now, if you notice, these equations here, I've got them over here on the board. If you guys look at this triangle, if I'm working with the angle B, it's going to require me to have the two sides that make it. So if I'm working with angle B, the two sides that make it, A and C, would have to be the things that are multiplied times the sine of that angle divided by a half. Okay, and I'm the same thing with the other two. The two sides that make the angle are multiplied together, and you multiply by a half. Why is that? How is that going to work that we're going to be doing this? If I'm looking at any triangle here, and you have A, B, and this is side C, okay, as we're talking about this. If this angle here, if I talk about that height as a right triangle, because remember, area of a triangle is base times height. Okay, no problem. Base times height, I got this. Well, if I've got a height, and in this case, my mythical height is a right triangle, opposite over adjacent, that's my A. So my height over A is equal to sine of C. Well, A sine of C, A sine of C is equal to my height. Well, area of a triangle is base, my base, times my height divided by 2. That's where 1/2 AB sine of C comes from. Okay, so it's not like it's a secret or anything. It's just finding the height without you physically doing it separately. It does it in a formula. So that's how the area of a triangle formula works with sines like this. So we're about to embark on using it. Okay. So as quick as it is, I'm going to find an area. Okay, so the area of the triangle, and actually this area of this figure, because it's regular, all 8 triangles are identical, right? And it's an octagon. So there's 8 of them. 1/2 times the radius squared. Okay, my radius is 9 squared times my sine. Sine of 45. Okay, I'm finding the area of one triangle. This one triangle happens to happen 8 times in this polygon. Okay. So it's 81 times 4. I'm just going to break that down. Sine of 45. Remember, the sine of 45 is the square root of 2 over 2, so really it's 2 times 81, the square root of 2. That's 162. Yep, 162. I can say it, but I can't write it. 162, the square root of 2, and that's units squared as I go through. It doesn't ask for me to do it exactly, but we know enough to do so, to get it done. Are there any questions about what I did with the formula? Part of that I derived the formula itself, okay, why it is what it is, why it was going to work, and why it's always the two sides that make the angle are the ones that are multiplied times the sine, and it's half because it's base times height divided by 2. Okay, so we're done. That's our answer. We're ready to move on to Heron's formula. Heron's, in this last one, I'm just going to pop this out right here. Heron's is just a formula where you have something called a partial answer on the formula itself. Okay, as you step through. It's an area formula for side, side, side as we go through. And all it is, and it's kind of an interesting formula, you use something called the semi-perimeter. Okay, the semi-perimeter takes half of the perimeter. You find the perimeter, you cut it in half. That's considered in Heron's formula the semi-perimeter, S. Okay, so in this problem, we got 13, 15, 18, add them together, divide by 2, it's 23. Most popular wrong answer when I look at someone's paper on this one is 37. Or excuse me, 37. 13 and 15 plus 18 divided by 2, and they only take half of 18, not half of the whole thing on top. So be careful as you do go through and enter it in your calculator. Okay, your calculator will do whatever you want it to, all the way up until you make an error that it can't do it, and it'll just return an error message. Okay, so keep that in mind. It's 13, 15, 18. Hit enter, divide by 2, should come out as 23. Now, how Heron's works. Pretty straight up. Okay, take your semi-perimeter and put it in. And you subtract off each side separately from it. You find the differences of the semi-perimeter in each side, and you multiply by the semi-perimeter again, and you take its square root. Okay. So eventually, all I'm going to do, I've got 23 times 10 times 8 times 5. Because that's the difference of my semi-perimeter in my original side lengths. Once I get that done, I can see from there. Turns this page. I should be coming up with 9,200. One would only hope. And it's 95.917 units.